Hello everyone, welcome to Infinity Learn by Sri Chaitanya. In this session, we will discuss Physics MPL paper Weekend Test 20. So let's start with question number 1. Which effect provides direct experimental evidence that light is a transverse rather than a longitudinal wave motion? So basically light can be polarized and this experiment provides the evidence that light is transverse, not a longitudinal wave motion. So correct answer is option 4. Next is question number 2. When unpolarized light is incident on a plain glass plate at Brewster's angle, then which of the following statement is correct? So, reflected light is plane polarized, but transmitted light is partially polarized when light is incident on a plain glass at Brewster's angle. So, correct answer is option 3. Question number 3. Magnification of a compound microscope is 30 and focal length of the eyepiece is 5 and the image formed is at least a distance of distinct vision. The magnification of the objective is. So, magnification is magnification of the objective into 1 plus d upon fe, which is pi, 25 upon 5. So, MO will be 30 upon 6 and that is equals to 5. So, correct answer is option 2. Question number 4. A Galileo telescope has an objective of focal length and magnifying power 50. The distance between the two lenses in normal adjustment will be. So when normal adjustment is there, the image will be at infinity, right? So in this case, a magnifying power 50 is FO upon FE and FE will be 50 FO upon 50. FO is 100 divided by 50, so it is 2. And the length of the telescope is FO minus FE and that is equals to 100 minus 2, that is 98 centimeter. So correct answer is option 1. Question number 5. A concave mirror having focal length 15 centimeter forms an image having twice the linear dimension of the object. If the image is virtual, then the position of the object will be. So this is a concave mirror. Focal length is minus 15 over here. And magnification is plus 2 because image is virtual and it is f upon f minus u. Right, so this is 2 is equals to minus 15 upon minus 15 minus u. This can be written as 15 upon 15 plus u. So after solving this one, you'll get u as 7.5 minus 7.5 centimeters. So correct answer is option 2. Question number 6. The phenomena used in optical fiber is, we use TIR, total internal reflection in optical fiber. Question number 7. Light ray travels from denser to rarer medium. If the critical angle of the denser medium with respect to rarer medium is C, the maximum possible deviation will be when I is equals to C and R is equals to 90 degree. So maximum possible deviation in that case is given as pi minus 2C, which is option 4. Question number 8. Radius of curvature of first surface of double convex lens is 3 times that of the other. So R1 is 3R and R2 will be minus R and focal length is 1 upon 30. So it will be 1 upon F is equals to mu minus 1 to 1 upon R1 minus 1 upon R2. So we'll get 1 upon 30 as 1 by 2 into 1 upon 3R plus 1 upon R, and after solving this one we will get R as 20 centimeter. So radius of the curvature of the first surface will be 3R, which is equals to 60 centimeter. So correct answer is option 3. Question number 9. A person standing at the center of the room 12-meter high looks into a plane mirror fixed on the wall. Then the minimum length of the plane mirror for him to see the full length of the image of the wall behind him. So minimum is h by 3. So it will be 12 divided by 3 and that is equals to 4 meter. So correct answer is option 3. Question number 10. We have two plane mirrors at an angle of 45 degree with each other. If an object is placed between them, then the number of images will be. So let's find capital N, which is 360 upon theta. So it will be 360 upon 45 and this will be 8. So N is even. So number of images will be N minus 1, which is 8 minus 1 is equals to 7. So correct answer is option 3. Question number 11. The ratio of minimum deviation of a thin prism in air and when dipped in water will be. So minimum deviation in air is mu g minus 1 into A, which is 3 by 2 minus 1 into A and that is A by 2. Minimum deviation in water will be mu of glass with respect to mu of water minus 1 into A. So it will be 3 by 2 divided by 4 by 3 minus 1 into A, and that is A upon 8. So let's take the ratio. It is A upon 2 divided by A upon 8, and this ratio is 4 upon 1. So correct answer is option 4. Question number 12. Flint glass prism is joined by crown glass prism to produce dispersion without deviation. The refractive indices of this prism for mean rays are known to be this and this respectively. Let the angle of prism of flint glass is 10 degree, then what will be the angle of prism for crown prism? So we know that A upon A dash is equals to mu dash minus 1 upon mu minus 1. So A dash will be A into mu minus 1 upon mu dash minus 1. So A is 10. Mu is 1.602 minus 1 divided by 1.500 minus 1. So after solving this one, you will get angle of prism for the second prism is 12.04 degree, which is option 1. Question number 13. The power of a biconvex lens is 10 diopter. So 100 upon f is 10. So f will be 10 centimeter. Radius of curvature of each surface is 10 centimeter. Then the refractive index of the material of the lens is. So 1 upon 10 is equals to mu minus 1 into 1 upon r1 minus 1 upon r2. So from this you will get mu as 3 by 2, which is option 1. Question number 14. Lens forms a diminished and erect image of an object. The magnification is 1 by 4 and the ratio of the object distance to focal distance is. So it is f upon f plus u, and f plus u is equals to 4f over here. Right, so u will be 3f. So u upon f will be 3 upon 1, which is option 4. Question number 15. An astronomical telescope has a angular magnification FO upon FE is 5 for distant objects. The separation between the eye lens and objective is 36 centimeter. Image is formed at infinity. We need to find FO and FE. So FO is 5 times FE. Put this value in equation 2. So we'll get FO plus FE, which is 5 FE plus FE. 6 FE is equals to 36. So FE is 6 centimeter and FO will be 5 times 6 centimeter, which is 30 centimeter. So correct answer is option 4. Question number 16. The refractive indices of crown glass prism for CT and F lines are this and this and this respectively. The dispersive power of the crown glass is omega is mu v minus mu r divided by mu y minus 1. Right. So this will be 1.35535 minus 1.527 divided by 1.530 minus 1. So after solving this one, you will get correct answer as option 1 over here. Question number 17. A simple microscope consists of a concave lens of power this and this. If the image is formed at infinity, then the magnifying power is. So we know that total compound combination power will be P1 plus P2, which is 20 minus 10, that is 10 diopter. So this is 1 upon focal length. So 1 upon focal length is 10. So focal length will be 1 by 10. And that is equals to 10 centimeter over here. Right, this is in meter. So this will be 10 centimeter. And magnifying power is D upon F. So over here it is D is 25 divided by F is 10. So it is 2.5. So correct answer is option 1. Next is 18. So through this gate you'll get A plus B. Through this gate you'll get output as this is B bar and this is C. So this is B bar plus C, and through this gate you'll get output as 1 A plus B dot B bar plus C. So correct answer is option 2. Question number 19. So we have for 0 0 input 0, for 1 0 again 0, 1 1 1, then 0 0 0, 1 0 1. So this is for AND gate. Next is question number 20. From the circuit of the following logic gates, the basic logic gate obtained is. So over here, this will be A bar, this is B bar, and this is B, and this will be A bar plus B bar whole bar, and that is equal to AB over here. So this is AB and B output for this gate. So this is AB dot B whole bar, which is equal to AB bar plus B bar. So this is A bar plus B bar plus B bar, which is equals to A bar plus B bar only, and A bar plus B bar is AB bar. So this gate represents what? NAND gate. Question number 21. The damping force on an oscillator is directly proportional to the velocity. So unit of the constant proportionality R. So force is equals to kV over here. So K will be force upon velocity. Force is kilogram meter per second square and velocity is meter per second. So it will be kilogram per second, and correct answer is option 1. Question number 22. Which of the following measurement is most precise? So this is the least measurement, and that is 8.00 millimeters. So it is most precise. Consider the following statements. A unitless quantity never has a non-zero dimension. That is true. A dimensionless quantity never has a unit. That is false. For example, angle. Angle is unit radian, but dimension 0. Right. So over here, A is true, B is false. Question number 24. A body travels with the distance of this and time of this, its velocity is. So velocity is distance upon time. So it is 24 upon 6, that is 4. Let's find the error. So it will be delta V upon V is equals to delta S upon S plus delta T upon T. Delta S is 0.2 divided by S is 24 plus delta T is 0.1 divided by 6. So this is delta V upon V. So delta V will be V times 0.2 divided by 24 plus 0.1 divided by 6. So V is 4. So after putting this value, you'll get it as 0.1. So correct answer is 4 plus minus 0.1 meter per second, which is option 4. Question number 25. The number of significant figures in the numbers are. So this has 1, 2, 3, 4, 5, and this has 1, 2, 3, 4, 5, 6, 7. We will not consider 10 to the power 4. So number of significant figures are 5 and 7 respectively, which is option 2. Question number 26. In vernier calipers, M division of MMSD coincides with M plus 1 VSD. So 1 VSD is equals to M upon M plus 1 MSD, and MSD is D. So least count is MSD minus VSD. So it is D minus DM upon M plus 1, which is equals to D upon M plus 1. So this is least count, which is option 2. Question number 27. The displacement of a particle is given as A sine pt plus qx. Then dimensional formula of APQ. So A should be equal to meter. So it is L. Uh, Net angle in sine should be dimensionless. So P should have dimensional formula of time inverse into Q should have dimensional formula of L inverse. So it should be T inverse only, which is option 3. Question number 28. In an experiment, four quantities A, B, C and D are measured with percentage error respectively. What is the net percentage error in P? So it is 3 times percentage error in A plus 2 times percentage error in B plus 3 times 1 time percentage error in C plus 1 times percentage error in D. So this is 3 plus 4 plus 3 plus 4, and that is equals to 14%. So correct answer is option 3. Question number 29. Using monochromatic source of light, Young's double slit experiment fringes have been obtained for a certain separation of the slit. As the slit separation increases, the fringes will become narrower because fringe width is inversely proportional to slit separation. Question number 30. A monochromatic beam of light is used for the formation of fringes on a screen by illuminating the two slits in the Young's double slit interference experiment. When a thin film of mica is interposed in the path of one of the interfering beam, then fringe width will remain same, but the pattern will shift. So correct answer is option 4. Question number 31. We have two coherent light beams of intensity I and 4I. The maximum and minimum possible intensities of the resulting beams are, so it is under root of I1 plus under root of I2 ka whole square. So this will be under root I1 plus under root I2 whole square. So this will be under root of I plus under root of 2I 4I ka whole square. This is maximum. So this is 3 under root I ka whole square, which is 9I. And minimum is under root of I1 minus under root of I2 whole square. So this is under root of 4i minus under root of I whole square, and that is equals to I, under root I whole square, which is I only, right? So maximum intensity is 9i and minimum is I. Question number 32. In Young's double slit experiment, if the intensity ratio between bright and dark fringes is 25 upon 9, मतलब I max upon I min is 25 upon 9, the ratio of intensities of the interfering waves is, so under root of I1 plus under root of I2 whole square divided by under root of I1 minus under root of I2 whole square is 25 upon 9. Take the square root on both the sides. So you'll get under root of I1 plus under root of I2 divided by under root of I1 minus under root of I2 as 5 upon 3. So this is 3 under root I1 plus 3 under root I2 is equals to 5 under root I1 minus 5 under root I2. Right. So this will be 8 under root I2 is equals to 2 under root I1. Right. So it will be under root I1 upon I2 is 4, and if you take the square, I1 upon I2 will be 16, which is option 4. Question number 33. Intensity of central fringe in interference pattern is 0.01. Then find the intensity at a point having path difference lambda by 3 on screen from the center. So I is given as I naught into cos square phi by 2, where phi is the phase difference. So lambda upon path difference is equals to 2 pi upon phase difference over here. So phi will be 2 pi by 3 and phi by 2 will be pi by 3 only, which is equal to 60 degree. Cos 60 degree is 1 by 2. So this will be I naught divided by um, cos 60 degree whole square, which is I by 2 whole cos 1 by 2 whole square over here. So this will be 4, and I naught is 0.01 divided by 4. So this is 1 by 4 into 10 power minus 2, or it is 2.5 into 10 power minus 3 watt per meter square, which is 2.5 milliwatt per meter square, and correct answer is option 1. Next is question number 34. In Young's double slit experiment, intensity at the point on the screen is 75% of the maximum value. So maximum value is I naught, and intensity is 75%, right? So this will be 3 by 4 of I naught, right? Minimum phase difference between the waves arriving at this point from the two slits will be, so I is equals to I naught into cos square phi by 2. So cos square phi by 2 will be root 3, 3 by 4, and cos phi by 2 will be root 3 by 2, right? So in this case, phi by 2 should be cos inverse root 3 by 2, and it is at 30 degree, right? So phi by 2 should be 30 degree and phi should be 60 degree. Question number 35. The resolving power of a telescope depends on, it depends on diameter of the objective, right? So correct answer is option 4. Next question is question number 36. We have two Polaroids P1 and P2 are placed with their axes perpendicular to each other. Unpolarized light I naught is incident on P1. The third Polaroid P3 is kept in between P1 and P2 such that its axis makes an angle 45 degree with that of P1. The intensity of transmitted light through P2 will be. So I1 will be I naught by 2, and I2 intensity through the second P3 will be I naught by 2 into cos square 45 degree, which is I naught upon 4. I3 will be I naught upon 4 into cos square 45 degree, so it will be I naught upon 8. So correct answer is option 2. Question number 37. We have traveling microscope is focused on a mark on a piece of paper, and the scale reading is A. A rectangular block of glass is placed on the paper and the microscope is raised and focused on mark on the paper. Then microscope reading is B. The paper is now placed on the block of the glass. The reading is now C, the refractive index of the material of the block. So it is mu is equals to real depth upon apparent depth, which is equal to option 2. Question number 38. Three lenses in contact have combination focal length 1 upon f1 plus 1 upon f2 plus 1 upon f3 is given as 1 by 12. When the third lens is removed, then 1 upon f1 plus 1 upon f2 is 1 upon 60 upon 7. So basically this is this value is 7 upon 60 and plus 1 upon f3 is equals to 1 upon 12. So 1 upon f3 will be 1 upon 12 minus 7 upon 60 and f3 will be minus 30 centimeter over here. So we have focal length negative, that means lens is diverging and having focal length 30 centimeter. Question number 39. A person can see clearly up to 1 meter. Find the nature and the power of the lens which will enable him to see things at a distance of 3 meter. So a person is suffering from nearsightedness, right? So it will use a concave lens. So power will be negative. So either this or this options are true. So over here, uh, object is at 1 meter and image should be at 3 meter by the lens. So 1 upon V minus 1 upon U is equal to 1 upon F. So focal length 1 upon F will be minus 2 upon 3 over here and it will be minus 0.66 diopter, which is option 1. Question number 40. A ray of light falls from air on a prism of refractive index √2. What should be the minimum value of I for which the total internal reflection will take place on side AC? So cosec I should be less than mu. So I should be less than cosec inverse mu and I should be less than cosec inverse √2. So I should be less than 45 degree. So, right. So correct answer is option 2. Question number 41. A plain glass slab is kept over various colored letters. The color which appears least raised will be red because of low refractive index. Question number 42. The circuit diagram shown here corresponds to which logic gate? So when A and B both are open, 0, 0 will get LED glow. So this will be output 1. When A is 1, B is 0, right? So LED will not glow because this is short circuited over here. Right, so it will be 0. When B is 1, A is 0, then again LED will not glow because it is short circuited from here. Right, so this will be 0 and both are 1, 1, then again LED will not glow. So this truth table is for NOR gate. Question number 43. To get an OR gate from a NAND gate, we need. So basically we can get it as A bar, B bar, whole bar as uh, OR gate from two NAND gates. So we need two NOT gates and from NAND gates and one NAND gate. So this will be option 2. Question number 44. If energy E, velocity V and time T are chosen as the fundamental quantities, the dimensional formula of surface tension is. Surface tension is F upon L. So F upon L will be E power X, V power Y and T power Z. So F is MLT minus 2 L inverse over here will be E is ML square minus T inverse 2 over here. V is LT minus 1 whole to the power X whole to the power Y and T power Z. So this will be L0 T minus 2 is equals to M power X L power 2X plus Y and T power minus 2X minus 2Y plus Z over here. So by comparing this, you will get the value of X as 1, Y as minus 2 and Z as minus 2. So correct answer will be option 4. Question number 45. Find the dimensional formula of alpha into beta. So basically alpha upon t square should be equal to Fv dimensional formula over here. So dimensional formula of alpha will be Fv t square ka dimensional formula, which is mlt minus 2 lt minus 1 into t square. So this will be ml square t minus 1 and beta upon x square should be equal to Fv dimensional formula. So beta dimensional formula will be Fv into x square dimensional formula over here, which is mlt minus 2 lt minus 1 into l square. So this is ml power 4 t minus 3. So if you multiply this one, you'll get m square l power 6 into t power minus 4, which is option 2. Question number 46. In Young's double slit experiment, we have two coherent sources placed at 0.90 millimeter apart and the fringes are observed 1 meter away. If it produces the second dark fringe at a distance of 1 millimeter by 2 is 3 by 2. Lambda d upon d is at 1 millimeter from the central fringe, which is 10 power minus 3 meter. The wavelength of the monochromatic light used is, so lambda is 2 D is 0.90 into 10 power minus 3 into 10 power minus 3 divided by uh, 3 into capital D. So after solving this one, we'll get wavelength as option 4. Question number 47. The central bright fringe of the interference pattern produced by the light of wavelength 6000 angstrom over here is found to shift to the fourth bright fringe after a glass plate of refractive index is introduced. The thickness of the glass plate is. So over here, basically 4 lambda, n lambda will be the location over here. So this will be 4 lambda is equals to mu minus 1 into T, right? So 4 into 6000 angstrom is equals to mu minus 1, which is 1.5 minus 1 into T, which is 0.5 into T. So after solving this one, you'll get thickness as option 4. Question number option 1. Question number 48. A beam of light of wavelength 600 nanometer from a distant source falls on a single slit 1 millimeter wide and the resulting diffraction pattern is observed on a screen 2 meter away. The distance between the first dark fringes on either side of the central fringe will be. So in this case, theta is lambda d upon A, right? So uh, theta into D will be uh, distance between the fringes over here. 2 lambda upon A will be angular separation, right? So d theta will be the distance over here, right? So this will be 2 into 600 into 10 power minus 9 into D is 2 divided by A is 10 power minus 3. So after solving this one, we'll get our answer as 2.4 millimeter. Question number 49. We have Young's double slit experiment. It is performed in air and then in a medium. It is found that eighth bright fringe in the medium lies where fifth dark fringe lies in air. The refractive index of the medium is nearly. So 8 into lambda medium d upon d should be equal to 2 into 5 minus 1 into lambda air d upon d, right? So lambda medium can be written as lambda air divided by mu. Mu is the refractive index of the medium. So this will be 9 lambda. So lambda lambda cancel. So mu will be over here. This is 9 lambda. Mu will be this is 2D. So 9 by 2. So mu will be 16 upon 9 and that is equal to option 3. Question number 50. Human eye has pupil diameter 5 millimeter. 2 points are situated at a distance of 50 meter from the eye. What should be the minimum distance between the points so that they are barely resolvable? Wavelength of the light wave is 5000 angstrom. So basically, if these objects are placed like this is the minimum distance. This is theta over here. And this is approximately 5 meter, right? And 50 meter over here. So delta theta should be this x upon 50 and that is equals to 1.22 lambda divided by t, right? So over here x will be 50 into 1.22 lambda divided by t and after solving this one we'll get x as approximately 6.21 millimeter, which is option